This slide shows the high-level structure of a generic autonomous system. The system gathers information through sensors or input channels and then needs to make sense of the gathered information. Next, the system needs to decide what to do based on this information. And finally, the decision needs to be put into action by the control component. It does this by interacting with the real world through actuators or output channels. As is shown, an autonomous system can include AI to varying extents. In some simple autonomous systems, such as basic thermostats, none of the functions are implemented using AI. Whereas more complex autonomous systems may use AI to support all three of the shown functions: sensing, decision-making, and control. If we consider this model in the context of self-driving cars, then sensing and decision-making are often implemented using AI, normally in the form of deep neural nets. However, control, such as managing the engine and brake components, is still often implemented using non-AI components. We already considered the need for flexibility in self-learning systems. Here we look at the ability of systems to evolve and how this is inextricably linked with self-learning. System evolution is defined as the system's ability to improve itself in response to external constraints. Ideally, such changes should improve the system's efficiency, effectiveness, or both. A self-learning system can learn from changes in the operational environment, such as climate change, and also from the effects of its own decisions and actions, such as with reinforcement learning, which we will cover in detail later in the course. Requirements for system evolution need to constrain the amount of change that the system can make to itself. For instance, not allowing changes to the system that would cause it to exhibit new unwanted characteristics, and of course ensuring the system's core requirements are still provided. These constraints will need to be specifically identified and the level of acceptable change defined for each relevant characteristic. These characteristics also need to cover how the permitted evolution is allowed to affect day-to-day human values, such as not causing harm to people, the environment, or animals. A major problem in specifying such requirements is that there is not normally a generally agreed definition of human values, because different cultures often have quite different values. For instance, some people seem to value the life of a pet more highly than the life of a person, as we will see later when we cover ethics. This has been the session in which I presented an introduction to some of those quality characteristics that are especially associated with AI-based systems, including flexibility, adaptability, autonomy, and evolution. Thank you for listening, and I look forward to seeing you next time. Thanks.